Okay, I just wanted to handpick a few of the questions on the review sheet in case some of you wanted a little bit of an explanation to go along with the answer key. Of course, you have access to all of these answers were released today in Google Classroom. But I'm just going to pick a few here. I didn't fill in the entire unit circle. I just filled in the pieces that I needed for the questions that I wanted to touch on here underneath. So we're going to start with number 3. 1 through 15 are all unit circle problems. So once again, the idea would be if you were going to answer all of these problems, you would have a fully completed unit circle directly in front of you. Okay, 2 really important things that you want to keep in mind with the unit circle is that we know when you've got these points, we know the cosine value is the x-coordinate, the y value is the sine coordinate, and the tangent value came from dividing the y-coordinate by the x-coordinate. So we're going to start with number 3. Anytime you are given an angle that is not directly, like you could directly locate it in the unit circle, you need to either add 360 or subtract 360 and write down on your paper where, like, what the coterminal angle is to that. So for example, negative 1,260, you're going to need to add 360 a few times until it lands on the angle 180 degrees. Now that's an angle we could locate on our circle here. Okay, now keep in mind, this is asking for tangent. So you're going to go to 180 on the circle, grab the tangent value, think of how that would look as a fraction. It's 0 divided by 1. But since this is a cotangent problem, we then want to take the fraction 0 divided by 1. We want to flip it and do the reciprocal. And if anytime 0 is in the bottom, that is when we actually say that our official answer for this would be undefined. Okay, let's go ahead and try number 5. Similar situation, 780 is not directly found in the unit circle, so you're going to need to subtract 360 there a few times until we see that, oh, okay, that's actually going to land right here at 60 degrees. This is a secant problem. Secant is the reciprocal of cosine. We know cosine to be the x-coordinate of the point. So when we grab 1/2 and we bring it down here, we are going to flip that so that we're saying the answer is really 2/1, or fine, just to write the number 2. Okay, all right, just a couple more from the unit circle. I chose 2 that were in radians. So what you would need to have written down on your paper is I would definitely need to see the degree measurement for what 3 pi over 4 converts to in degrees. Of course, we know to convert, we multiply by 180 over pi. The pi symbols cancel. We see that converts to 135 degrees. So we're going to go to tangent at 135. Okay, that 135 is here. I'm directly grabbing the tangent value. I do not need to do the reciprocal. This is just asking for tangent. There we go, -1. Okay, and then for cosecant of 8 pi over 3, very similar. We're going to want to convert this into degrees. We'd cancel the pi symbols, 8 times 180 divided by 3. Initially, that comes out to 480 degrees, but then we would need to subtract 360 degrees off of 480, that tells us we're looking really for cosecant of 120 degrees. Okay, now once again, remember cosecant is the reciprocal of sine, and sine is the y-coordinate. So I'm going to go to 120 degrees right here. I want to grab the y-coordinate, but then I need to do the reciprocal of square root of 3/2. Okay, so I'm going to just work this out off to the side here. I'm going to do the reciprocal, so I'm going to put the square root of 3 in the bottom, 2 in the top, and then I have to go through the process of getting rid of the square root of 3 in the bottom. So technically, the answer that I need to be writing for cosecant of 120 is 2 times the square root of 3/3. Okay. You did not need to do number 16. I also think there may have been like a 21 and 22 at the bottom. You don't see anything here, but you did not have to do those last 2 problems either. Okay, let's take a look at number 17. Okay, here's one in degrees. I went ahead because I'm hoping that you guys are all okay with answering the first three questions. We said yes, that it's flipped because it's negative. We said the amplitude was 3, and we said the midline's at 1. You'll notice I went ahead and prepped this. I put the midline at 1. Knowing that the amplitude was 3, I marked off so I'd have enough room to stretch up 3, and then that I'd have enough room to stretch down 3 from the midline. Okay, now what I still have to do though is I still have to figure out where does this wave start and where does this wave stop. And so what you're going to do is you're going to grab the part that's in the parentheses here. That's the 3x minus 180. You're going to want to put that, since this is degrees, you're going to put that between 0 and 360. Okay, we're going to proceed to get that x in the center all by itself. So I'm going to add 180 to all three sections here. Okay, that's going to make this initially 540 on this side, but then I'm going to divide all three sections by 3. That gives me 60 on the left, x by itself in the middle, and 180 all the way on the right. Okay, that's what I'm going to highlight because this 60, that's the phase shift. Okay, now the 180, be very careful, 180 is not the period length. Okay, 180 is actually where the period ends. So if you want, you could come right over to your x-axis and mark the wave starts at 60. Go ahead and mark over here that it stops at 180, and we'll come back and fill in the middle and 1/4 and 3/4 in just a second. Okay, period length, remember that's where it ends minus where it begins. So I'm going to take 180 minus 60 period length. That means the length of this wave is 120 degrees. Okay, to get the very middle, this is averaging. This is where on your calculator you would take 60 plus 180, hit enter, divide that by 2. That's going to give you the middle of this to be 120 degrees. Then we're going to follow that same procedure here. We're going to average 60 and 120. We divide that by 2. That's going to give you the 1/4 mark at 90. And then again, average the middle and the end. We would add those together, press enter, divide by 2. That's going to give you 150. Okay, very important you have those 5 labels there. Okay, now we're ready to place points on the midline. We look back and say, well, what wave are we sketching? We're doing the sine wave. I should put points directly on that dotted midline at beginning, middle, and end. And then I take a glance and say, well, am I supposed to flip this? We said yes. So instead of stretching up 3 first and then down 3, I'm going to go down 3 and then up 3. So I want to count down 3 units from the midline. That puts me at -2. And then at the 3/4 mark, which is at 150, I'm stretching up 3 units up to 4. Okay, and there is my sine wave. Okay, let's do one last one here in radians. Okay, I went ahead and answered those 3 blanks. I'm not going to talk through that part there. If you have questions, just message me. Okay, I'm going to grab this part in the parentheses here, only now I can see this problem is not in degrees, it's in radians. I know that because I see this pi symbol right here, so that means I need to be putting 2 pi over here, not 360 degrees. Okay, I'm going to need my calculator close here, because especially when I get over here to this far right side, because I'm going to want to type into the calculator 2, and then I'm going to subtract from that 1/6. Okay, this is what I'm going to type in. And then I'm going to switch that back into a fraction. Okay, this is not averaging. I'm not dividing by 2. I'm just combining these together here. So 2 minus 1/6. And then I switch that back into a fraction. I should see 11/6 on my screen, and I reattach the pi symbol. Okay, since we've got a lot of fractions happening here, I'm going to get rid of the 1/2 by multiplying all 3 sections by the reciprocal of 1/2 by 2. Okay, now when I multiply this together here on the left, I could get -2 pi over 6, or I could reduce that to -1 pi over 3. And then over here on this side, I could write it as 22 pi over 6, or I could reduce that and write that as 11 pi over 3. It is best, before you label and identify things, that you make sure that it is officially reduced. Okay, so here's my ending inequality. All the way over here on the left, that is the phase shift. Okay, I notice that it's negative, so I'm going to go ahead and mark that this is negative pi over 3. Okay, the period length is where the wave ends, minus, oh, I got a double negative here, minus where it begins. So it's going to end up being 11 pi over 3 plus pi over 3. Okay, when I combine that together, I get 4. I reattach the pi symbol. The length of this wave is 4 pi, but I'm not marking 4 pi over here. I'm grabbing where the wave ends and marking that over here. So over here is 11 pi over 3. And then I follow my strategy of on the calculator, I do -1/3, I'm averaging now, plus 11/3 divided by 2 because I want the middle of those. Okay, I do that. I end up getting 5/3 on the calculator. And then I attach the pi symbol, same strategy, take -1/3 plus 5/3, divide that by 2. I get the 1/4 mark. Oh my, this is not drawn to scale well at all, but that's 2 pi over 3. And then finally, if I average 5 pi over 3 and 11 pi over 3, I end up getting this to be 8 pi over 3. Okay, now I'm ready. Looks like we're doing the cosine wave this time. So I'm going to place points. They got to go on the midline, though, at the 1/4 and 3/4 mark. We said yes to the flip. So instead of starting up, going down, and then ending up, we are starting down, and we're going down 3 units from the midline. So I'm going to start down here at -2. Then in the middle, I'm going to go up 3. And at the end, I'm going back down 3 again. And there's my graph.